we are going to review for quiz 3. But first, I want to be very, very, very explicit about something that I've kind of hand-waved my way through. So, bear with me. There is method to my madness. I've measured this. It is 1 unit long. I've also measured this. It's 2 units long. What must this length be? Root 3.
You didn't measure.
Meaning that this is what angle? Pi over 6. Meaning this is what angle? I don't actually care about him right now, but you're right. That's pi over 3. Okay, so check this out. I also have this. And it turns out that this is exactly half that length. It's exactly half that length, and it is exactly half that length. So what must this angle be right here?
Third.
No,
Pi over 6.
But it has to be the same angle, right? Okay. So there's, pi over 6. Oh. And in case you don't believe me, like, look, right? Like, that's the same angle, okay? And so, therefore, what's this angle right here?
Pi over 6.
Still pi over 6, right? That hasn't changed. We believe that, okay? Now, if I told you, and as you could see, if you don't believe me, but trust me here, this is exactly a half of that length, making this length right here what?
1/2.
1/2. Okay, so I'm going to write it on there. This length is 1/2. Okay, and therefore this length right here must be what?
The hypotenuse.
The hypotenuse is it's 2 over 2 or 1. Okay, so there's 1 right there. A nice 1. And therefore this length from here to here must be what?
Root 3 over 2.
Root 3 over 2. Okay? Now, what about on this side? Is anything different?
No.
So this is still what?
1/2.
1/2. And this length is what?
1.
1. And this length is what?
Root 3 over 2.
This is still a right, I don't do that, but that's root 3 over 2. And this is indeed that. Okay. This is what I've been implying this, and I've been saying it, but I want us to be really, really sure about this. So, okay. If my angle is pi over 6, right? And if this is 1, then this point right here lands on the unit circle. Which means that its x and y coordinates are by definition now the values of sine and cosine. So what's its x coordinate here?
Root 3 over 2.
Root 3 over 2, right? This length is root 3 over 2. What's its y coordinate?
1/2.
It's 1/2. Which means that sine of pi over 6 equals what?
Root 3 over 2. No, 1/2.
1/2, right? Because you can think about it 2 different ways. Opposite over hypotenuse, which gives you 1/2 over 1, or 1 over 2, same thing, right? Or you can think about it as a point on the unit circle and say, well, that's 1/2. That point right there is the height is 1/2, and that's sine. That's how we got sine. Now this is stuff we've already talked about explicitly. But this is what I mean by the utility of reference angles here. So, when we had something like this, I think you probably saw this in your homework, where we have the sine curve, and we want to know where is it equal to 1/2, right? And we could see, okay, there's 2 places where that's going to happen. And when we talked about this last time, I said, all you need to do is figure out what it is in the first quadrant, right? And then, because if you know that it turns out to be pi over 6, then all the other ones must be over 6 as well. Okay, we're going to do something right now. And for right now, do not worry about the pluses or the minuses. I just want to say sines, which
Symbol.
is so confusing, right? Okay, so don't worry about pluses and minuses right now. I just want you to tell me in absolute value. I'm going to ask you something. In absolute value, what is sine of that angle?
1 half.
In absolute value, what is sine of that angle?
Also 1.
In absolute value, what is sine of that angle?
1.
Right, it's just the length, right?
Yeah.
In absolute value, what's the sine of that angle?
1 half.
It's still just 1/2, right? So it's like, if your sine is equal to 1/2 or negative 1/2, right? There's two possibilities here. And what we're talking about here is, let's say if it's negative 1/2, then you have to take this stuff into account. But the only way to make this output equal to either 1/2 or negative 1/2 is if it's this triangle right here. The only way that sine of something can be 1/2 or negative 1/2 is if this angle is this angle right here. That's the only possible way to make it happen. Then the only thing that's left to figure out is, well, where could that happen? And I guess sine is positive up here, right? Sine is also positive right there. So those are the two places. And like I said, it's we don't want to think about it as being on the unit circle because that's kind of a pain. But if you look right here and you believe what I'm saying about reference angles here, saying like, well then, the other thing here must be the same triangle as long as you're measuring, because remember we're talking about sine being height. And so we're measuring like this, not like this, right? Or, I mean, I guess this does work, but, we're always measuring like this, right? And so, well, and always with the, yeah, yikes. And so, if you know that the height is 1/2 like this, then the only question is, well, I know that that angle right there has to be pi over 6, which makes the full, okay, so that makes this angle what? Wait, from there to there,
Pi minus pi over 6.
which would be what? If you have 6 pi over 6.
5 pi over 6.
5 pi over 6, right? And if you remember the very first thing I told you to memorize, right? This is 5 pi over 6 right there, right? And so you know that this must be 5 pi over 6. Similarly, if it's negative, you could think about it like this and say, well, hold up. If the output of sine is 1/2, it has to be this triangle. It has to be that angle. There's no other way of making a triangle that does that, as long as we're talking about positive stuff. But now the question is, well, now it's negative, so what do I do? And so, well, that's how you make the length 1/2 a negative number, right? You put it down there, which then, in that case, what would this angle be? All the way to here, for measuring it all the way to there, so that angle is what? 7 pi over 6. 7 pi. This is what I was saying. I didn't go explicitly like I'd like to do with this stuff. I just kind of said, once you know the reference angle, then you know that and this is why you know this stuff. Because again, pi over 6, this is the only other way to make a negative 1/2 right there. That's negative 1/2 in the height direction, right? The only way to do that is with this very triangle right there, which means that the actual full measure of this angle is what?
11 pi over 6.
That would be 11 pi over 6. And so then we have these two right here, which are 7 pi over 6 and 11 pi over 6. So I kind of like this as a visual to see why this is the case, right? And like I said at the beginning, if I oriented it like this and said, what's pi over 6? What's sine of pi over 6? You say, well, it's 1/2, right? So this is what I mean here. Like, it doesn't matter which way you orient it. And just having this right here is going to make your life so much easier because we're always talking about reference angles as being the triangle you make if you put the right angle there and something like that. So it's like that, or it's like that, it's like that, or it's like that. And then all you have to do at the very end is just ask yourself, well, is that positive or negative, and blah, 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 blah. We could play the same game with root 3 over 2, right? Root 3 over 2 is positive over here, therefore cosine of pi over 6 must be that. And so if we're looking at cosine, and we want to ask, okay, where is this guy equal to root 3 over 2? The great thing about the graph is it can tell you where to look. Here, since this is pi over 2 and this is 3 pi over 2, I know that I must be looking in the first quadrant and the third quadrant. Or if we're just thinking in terms of x values, you'd say, well, if cosine's positive, you must be over here somewhere. And I know that cosine of pi over 6 is root 3 over 2. Or if I shrank it, it would be root 3 over 2 over 1, right? Because cosine is adjacent over hypotenuse. And so you're right there. And so you'd say, oh, it's pi over 6. The only other way to make that happen is if it's flipped down like that. Still pi over 6, but now it's not just pi over 6. You have to take the whole thing into account. It would be 11 pi over 6. And so we'd be here at pi over 6 and 11 pi over 6. Okay? Questions? Making sense what I'm talking about? I mean, and maybe you perfectly understood all of this last time we were talking about it or the time before. That's cool. I like to be very, very clear about why this is, why I said what I said, you know, like what it means, etc. Okay, are we good?
Yeah.
Any questions before we start reviewing for this quiz? Any questions at all?
What's your favorite color?
Blue, I think. Peter seems to think my favorite color is red. I'm like, it's blue. He's like, you like red. Okay. I think it's blue. At least today. I like turquoise. Turquoise is cool. Okay, so this is your quiz. So first thing I'm going to say is know how to change this thing. I'm not going to go into this. I'm just going to say what I'm going to say. If you have any questions, either consult your notes or look at the video when we talked about this. Know how to turn this thing into this thing. And know how to turn this thing into this thing. No. No. Know how to do that. If you know how to do that, you'll be in good shape. Now it's gone. It's gone. Ha! You should know that already. So, okay, there's that. Now, you're going to have to prove some identities. Like I said, in pretty much every quiz we do from here on out, you're going to have at least one identity to prove. And one thing I want to say about that. So, actually, you know what? I'm going to be really cool here.
Does identity just mean like an equation?
It's an equation where involving sines and cosines and all that stuff, and it says, you know, prove that this is true. So I'm going to go ahead and narrow down for you guys. We're going to say I think it's section 6.2. Yes. Give me just a second. In section 6.2, so that would be on page 427, 428, there's a bunch of identities and stuff there. And if you know how to do all of the even numbered ones, you'll be in good shape for this quiz. Now, okay, there's something I want to say about that, though. There's one one of these where you could look at it and think, oh man, and like you may or may not see it. Like, so usually with identities, what I've said is you start with one side of the equation, usually the more complicated side, do some magic and turn it into the right-hand side of the equation. So, I just want to put all that stuff away.
The magic is the hard part.
The magic's the hard part, right? So, actually, yeah, I'm sorry guys. I should have thought this ahead. I do want to do an example. Okay, so, for instance, this was one, I think this was one from your homework. And so, secant theta minus cosine theta equals tan theta sine theta.
Oh, this one was hard. I think.
I think it was. So here's the thing.
What number was this?
This was 63.
Yeah, this one.
Yeah. So now there's a bunch of ways we could think about this. And what I've suggested is you take one side of the equation and try to turn it into the other side of the equation. And so, now here's the thing. You're going to be taking a quiz, and you're going to be pressed for time, okay? And I understand if that doesn't work out quite the right way. For instance, this is what your work might look like on the quiz. You start here, and you do something like this. Okay, I'm going to start with the left-hand side of the equation, like Mr. Thompson said. And so I'm going to do this. And so you go, oh man, what do I, well, you know what, maybe I'm just going to do some scratch work and maybe I'll work on this side of the equation. And so you have this right here. And so then you go, boy, you know what, I guess that's the same thing as this. Oh, but wait a minute. Oh, but wait a minute, wait a minute. This is the same thing as this. Over this.
Yeah.
And then you go, oh, you know what? Oh man, look at this. And so what you've done here is you've worked on both sides of the equation, and now you're at a point where you could say, hey, look at that. That is the same thing as this. And if you're pressed for time, it would be much better for you to have this out there and then be like, look, like, hey, it's equal, okay, and I get it, and you'll totally get credit for that. But what would be really cool, what I'd much rather see is this, if you have time, this is your work, and now I'd like for you to put it all together. So maybe you do something like this and go, okay, hold up. I could fit this all together. I'm going to start with one side of the equation, and then obviously these are both ugly. So start with either side. But I'm going to start with one side and go, okay, secant theta minus cos theta is equal to 1 over cos theta minus cos theta. And now you say, aha, that's where that came in, which is the same thing as, and maybe you skip a step because you're like, I'll just go here because I'm running out of time. This is fine. This is the same thing as this. And now I'm just working my way backwards and saying that is that. So that's the same as sine squared theta over cosine theta, which is the same thing as sine theta times sine theta over cosine theta. And I stop and go, is that true? Yeah, okay, that's true. I'm good. And then I go like this and say, that's tan theta sine theta. This would be a perfect answer. And then you put it in a box and you say, that's my final answer. That would be perfect. If you can't get to there because you're running out of time or whatever, you'll totally get some credit for this. You'll get a lot of credit for this if you have it all spelled out. But what I'd like to see is this. But don't flip out if you can't connect the dots. And another thing is, if you're just struggling with one side of the equation, like start working on the other and you can see how to put it all together, right? Because sometimes it's not obvious, like to me, certainly not obvious how to get from here to here, right? But that's why you might need to work on this. But ultimately, for a perfect answer, and for all of your homeworks, I don't want to see this in homework. I want to see this right here, right? This, you do your scratch work and you see how they're connected, then you flesh it out for certain like that. Now, there is one of these on here where I swear you could look at it and go, oh, I could see how I can manipulate this entire equation and make it true.
Oh, okay. I think things to the side.
Yeah, so like for instance, now it would be amazing if I could just pull this out right away and see how to do this. But you know what? Let's try it. So for instance, now with this one, I'm not going to say like this, the way that I'm about to do this is the way that you should tackle this one. The way that we just did it is probably the most straightforward way. But there's one on there where I swear you could look at it and go, oh. And maybe you don't, and that's cool too. And maybe you want to start on one side and just roll with it and turn it into the other side. That would be really good. But if you happen to see something, like what I'm about to pretend to see right here, if you do this, and you go, wait a second. Huh, this is the same thing as this. And so you're operating on both sides of the equation simultaneously. And you go, this is this. There's sine. And so I have another sine here. And then you go, huh, you know what, I can multiply both sides by cosine. And so I multiply by cosine and I get 1 minus cosine squared theta is equal to sine theta times sine theta. Right, because I multiplied both sides by cosine. Right, everybody saw that? I multiplied by cosine, it hits that, gives me that. Comes over here, hits that, cancels that, gives me that.
Yeah.
And now you go, oh, wait a second, 1 minus cosine.
I don't know how you would see that.
Yeah, you wouldn't. Yeah, this is what I'm saying. Like I'm gonna pretend I just saw that. Like I didn't see that, right? And then you end up with, oh, look at that. Hey, that's true. Now, here's the problem with that, though. Yeah, but you didn't start with something you knew, right? Like you started with something you didn't know was true, and then showed that this was true. So if you do this, there's one on the quiz, I'm telling you, where you could easily see the trick and go, oh. What I'm telling you is if you do that, that's great. Then say that's just like before, say that's my scratch work. Here's my final answer. 1, you start with the thing that you know is true. We know that this is true because we proved it in class. Now I'm going to work my way backwards to show the thing that I don't know is true to be true, right? And so now I take a few more steps and I'm just going to repeat each one of these lines until I get back to the thing that I'm trying to prove. Everybody understand why that logically is much better?
Yeah.
Right? Because it might be the case where taking a step in this direction works, but then if you try to take a step in the opposite direction, it doesn't work, right? Like if you're trying to prove something with square roots, you know, and you end up taking a square root in your thing, and you're like, oh, okay, and then you just assume, oh, they all work, they work fine going in the reverse direction. Well, no, it doesn't work always fine in the reverse direction. And so that's what you're doing here. You're saying, okay, look, it works this way. I'm pretty sure each one of these steps are reversible. And as I'm writing it out, I'm going to check that and say, yep, everything's fine. And so this is my final answer. So that's what I want to see, okay? If you happen to work on both sides of an identity, and then you end up proving something that's true, but that's not what you're doing. Logically, you have to start with the thing that you know to be true and derive from it the thing that you're trying to prove. Questions on that? So help me, if any of you don't do that, you get a 0 for the year. No, not really. Okay, so now let's do this. You're going to have one like this, where I say, find the values of the 6 trigonometric functions, blah, 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 blah. Find thous of the 6 trigs of theta if theta is measured from standard position. Standard position. If theta is measured from the standard position and the point.
Do you write it like this on the quiz?
No, it's all written out, and I even I even say the finds of theta, and then I put in parentheses, i.e., sine theta, cosine theta, etc. Right, in case there's any question. And the point. Let's just say, oh, how about 5 comma -3 is on the terminal side. Okay, we did these in class. You had homework on them. I want to go through this just to give you one, okay? So you're going to see something very similar to this. And what we're taught, just to be 100% clear of what I'm talking about here, is we're imagining that we're measuring some angle theta starting here where theta is equal to 0, and we move in the counterclockwise direction to some point. In this case it's 5 comma -3. So there's a point 5 -3, and that point is on the terminal side. That's how your book put it. And so theta is like this. Now, the way that we've done this, right, is we drop the perpendicular this way, so that that is perpendicular angle. And we consider this da 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 da. So you tell me, if this is the point, 5 comma -3, what other information do I need to know to be able to solve this? I need to know the hypotenuse, which is what?
-3 squared plus 5. Yeah. Well, equals C squared. Yeah.
So, what is that?
Root 34.
Root 34. Okay, so that guy right there is root 34. So wait a second. This, in other words, the radius, you're telling me, is equal to whatever that first thing is squared, and then whatever the second thing is squared? Is that what you're telling me?
Yeah. Y.
Right?
R
Right?
squared equals Y.
So if I had a 9 and a 22 in there, you would do 9 squared and 22 squared and take the square root and tell me that that's what that is?
Yes.
Yeah? If I had, I don't know, a smiley face and a frowny face, you would take the smiley face and square it, and then put the frowny face and square it, and tell me that's what the square root is, and you'd write that as the length? Okay. Okay. Okay.
Did we miss something?
Those who have ears, let them hear. So, sine theta equals what in this case?
A. No. Yeah. Y.
The y value, which is what? What is the y value?
Oh. -3.
-3. Uh-huh.
34.
Yeah. Right? Because another way we could think about this is saying, oh, this isn't on the unit circle. The unit circle is actually right here. And so if we wanted to do that, we would need to shrink this radius to 1.
Yeah.
And if we shrink that radius to 1, it would be 1 over 34 on each side. And so that would be minus 3 over root 34. And then that length would be, I guess, 5 over root 34. But however you want to think about it, I think it's much easier once you have a triangle drawn. You just go opposite over that. And then for cosine, you go what? Which in this case of this big old triangle, there's your reference angle. We said this was a -3, and that length was what? That length right there. Whatever showed up there. Like if that were a exclamation point, you would take whatever that is
Is there going to be that on the quiz?
I don't know. And you do it over whatever that happened to be. And so if it were an exclamation point and a star, you'd say, well, the radius is exclamation point squared, star squared, and then I guess whatever exclamation point is, that would be the top. And so then it would be an exclamation point, and that would be your cosine theta. Don't make it harder than it needs to be, right? Now, it's nice when you could just draw it out there, right? And you could see, oh, that's where 5 and negative 3 are. But would it matter if you didn't know where 5 and negative 3 are? Because that's the whole thing about this, is whatever number this happens to be, that's the number that shows up right there. Whatever number that happens to be, that's the number that shows up right there. Whatever numbers that happen to be squared, that's what shows up in the square root. One last one. What would tangent of theta be?
It's negative. Yeah, negative 3 over 5.
Oh, so in other words, whatever showed up right there divided by whatever showed up right there. Yeah, okay, I think I've made my point. All right. Okay, so now we're going to have two of this flavor of what you did for homework this last time. And so this last one that we talked about, right, this is actually like, the reason I didn't skip that section entirely, because as you know, that section defined cosine and sine in terms of xy coordinate and a radius. And I already told you guys we weren't going to do that. We're going to just talk about the unit circle. That's how we're going to define sine and cosine. But I went through it anyway because it's a really good, like it ends up being very useful. Very often you have a point out here somewhere and you know its coordinates. Like you know its coordinates are 18 and negative 7. And for whatever reason, it's really important to be able to figure out what this angle is. And if you could figure out, well, you know, I know, for instance, that tangent of this angle, what would tangent of theta be in that case?
Negative 7 over 18. No, 18 over negative 7.
Mm-hmm.
Yeah.
Right? Because just think about it. If you get confused, right, just like, well, hold up, wait a second. Tangent of that triangle would be opposite over adjacent. Opposite is that. And so 18 over negative 7. There we go. Okay? And so you can find theta. We're going to talk about that before too long. If you have this, you can solve for theta.
How do you get the theta out of the tangent?
You'll see. Boy, you'll see. But that's the idea, right? So it becomes really important to be able to think about it both ways, right? So that's why that's why there's a quiz question on it, because it's a very good skill to have. If you could find all the trig functions, given a point, and thinking about that as an angle, it'll make your life much, much easier. So, here we go. Find all values of x. Of x satisfying some equation. And let's do, which one do I want to do? I don't want to do that. I do want to do, let's go cotangent x is equal to, let's do cotangent x equal to 2, and now I have to give you on an interval. Yeah. And let's go negative 2 pi up to pi. Okay? So, first thing you want to do here is what? Graph it. You gotta graph this guy. And so, I'm gonna need more room on the left hand side. Okay, now the way I remember cotangent is I just remember it comes down from here. This is how I remember this one. It comes down and goes through like that.
Oh.
And it has an asymptote here. And then I ask myself, wait a minute, which one's which? What is, and so then I think, okay, well, cotan is what over what?
Cosine over sine.
Cosine over sine. So it blows up where sine equals 0. I know sine comes up, it comes down here at pi. So this must be pi over 2. There we go. And then this thing just repeats over and over and over again. And so we're as far right as we need to be. So we're just going to need to take this block and bring it back 2 places. And so it must be here at negative pi. And it must come down and go through like that. And again, since that's just been picked up and moved over 1, that must be negative pi over 2. Now I'm going to double check. If I plug a negative pi over 2 into here, I have cosine of negative pi over 2 over sine of negative pi over 2. And I just think, okay, cosine does this thing. And yeah, indeed, at negative pi over 2, it's equal to 0. Sine does the opposite thing. It comes down like this. And so at negative pi over 2, it's negative 1. So no worry about division by 0. I must have the correct stuff going on. Okay, I'm good. So I'm going to do one more of these guys. And so that must be negative 2 pi. It must come down and do this. And where does it go through right there?
3 pi over.
Yeah, negative 3 pi over 2. Okay, now we want to know where that value on this interval gives me root 3 over 2. Is that a positive number or a negative number?
Positive.
Positive number. So it doesn't matter how I draw this. I could draw it as high or as low as I want. As long as it's above the x-axis, we'll have enough information to figure this out.
3.
We are expecting 3 of these bad boys. So I want to start in the first quadrant because I think that's going to be the easiest to figure out because I can see, aha, okay. Now, what triangle do you know that has these numbers in it?
30, 60, 90.
30, 60, 90. So let's draw it and see here. Three, oops. Oops. Okay, let's try that again. So, final values of x satisfying cotangent equals root 3.
Oh.
Yeah, that wouldn't have worked. So, yeah, that's...
Cosine.
Yeah, it would have to have been either a cosine or a cosecant or something like that, right? So, okay, sorry. So, here we are. That's root 3. Everything we've done is still not... This is the great thing about this. Like, it's... as long as it's positive, you can see where all of your values are going to be. It's a positive number. Okay, so then there's 2 possibilities here. Pi over 6 or pi over 3. So, which one gives me cotan root 3?
Oh, it's...
Which one is it?
It's... adjacent over opposite, so then it's root 6. I mean pi over 6.
Pi over 6, okay. So here we go. Pi over 6, this is adjacent. This one's opposite. So adjacent over opposite is cotan. So then it must be the case that cotan pi over 6 gives me that.
Yeah. And now the others are...
So, in other words, right, cotan would be that over that, right? So I'm thinking about the unit circle now. So that we know it happens in the first quadrant. It happens in the negative, so that must be the fourth quadrant. So it must be down here. And it happens in the, first quadrant. Oh, that's the second quadrant. Okay, whoa. This is the cool thing about going backwards. We have to use our brains here. So we know that this is pi over 6. Now we have another one here. What quadrant is that in? You're between negative pi over 2. This is where
third.
this is where this might help you out to go
that's
like
what I
this.
thought.
Negative pi over 2, negative pi, negative 3 pi over 2. And so now we've gone past this, right? That was negative pi over 2.
Oh, because
And
it's
n-
negative.
Yeah! And so we must be in this quadrant somewhere. And so this must be my pi over 6, right there. Making this full measure what?
7 pi over 6.
7 pi over 6. There we go. So there's 7 pi over 6. Now let's figure this out. We're still going backwards, and we go through
It's minus 7.
pi right here. So working our way backwards. Whoops. This is what we're doing. We're starting here at 0. We work our way backwards, and we're there. We work our way backwards to pi, and we're there. We work our way backwards to negative 3 pi over 2, and we're there. Now we're somewhere over here.
Okay. So that's pi over 2. I mean pi over 6.
Regular old pi over 6, right? But what is that in terms of this guy?
Negative 11. Wait.
13 pi.
Yeah, but negative 11 pi over 6, right? Because 13 pi over 6 does not live there.
Yeah.
This is the tricky thing about this going backwards, right? Like, you'd have to say, well, this would be minus 2 pi. And that's kind of what we're doing here. We know that this distance from here to here is pi over 6. And so it's like, well, minus 2 pi, and now we're going to go back, so we're going to plus pi over 6. That would be negative 12 pi over 6 plus 1 pi over 6. So negative 11 pi over 6. Now you're right to say that's the same thing as pi over 6. But we already got that one.
Yeah.
Right? And so like we have to really think about this and say, well, wait a second. Like I'm trying to find a point here. Negative 11 pi over 6 does live right there. That's negative 11 pi over 6. So like at first, when we were first doing this, you could easily discount like, well, you say negative pi over 6. That's the same thing as 11 pi over 6. And like, yeah, while that's true on a circle, now we're talking about real numbers. We're talking about the real number line. So all of this stuff is important now. And we have to actually use our brains. So, good luck. That's, that's fun. So let's do another one. Since you're going to have another one. So can I get rid of all this?
Yeah.
Okay. All right. And I erased my preamble. It's the same thing. It's find all x vowels satisfying. And I wanted to do cosine x equals negative root 3 over 2 on, let's make it big. Let's go from, yeah, 0 to 900, no, let's not do 900 pi, let's just do 4 pi. That's much more doable. Okay, so what's the first thing we want to do? Draw cosine. And I know I don't need to worry about it when it's negative, so I'm just going to do it over here. And I'm going to go, cosine starts here? No. Where does it start? Down here?
At 1.
It starts at positive 1. Comes down. Up. Yeah, I didn't draw it big enough. Comes up. Okay. That's 2 full periods, and I could see because that's 1 full period, so that's 2 pi. Here's my other full period there at 4 pi. Making this value what?
Pi.
And this value what?
3 pi.
And this is what?
Pi over 2. 3 pi over 2. Or 500. So.
Nice. Okay. Now, is this a negative or a positive? It's a negative. It's a negative value. So the only, as long as you're not, unless that value happens to be -1, in which case you're done. You say it's pi and 3 pi,
Yeah.
or at least for sine and cosine. It's not that way for tangent.
Yeah,
and
there were a few like that.
right? Like, yeah, but sine, cosine, secant, and cosecant, if the output value is 1 or -1, that's your life is pretty easy. For the other ones, it's not so easy. But in this case, okay, so we're somewhere between 0 and -1. So it doesn't matter how I draw it. This isn't, you see what I mean, right? Like if I put it up here, you're going to say, well, the value must be here in the second quadrant, or wait, yeah, second quadrant, and you'd be correct. If you draw it way down here, you're going to go, well, my value is somewhere in the second quadrant, and you'd be correct. That's pretty cool. So I'm just going to draw it in the middle just to give myself a little bit of room. -3/2 is going to come over, hit there, hit there, hit there, hit there. I'm going to have one here, have one here. Okay. So what triangle do we know?
36.
That's the 30, 60, 90 triangle.
Well, the first one's easy, right? It's just, wait, no, it's
Which one of these gives you cosine?
We want
it's pi over 6.
pi over 6.
Right, because
One over-
cosine, so what we're saying here is cosine pi over 6 equals √3/2. So in other words, we're talking about this length right here. And the only other way to get those in all the other ones is if it's like this, or if it's like this, if it's like that, or if it's like, so right, because you're looking for where are the x values of this thing equal to √3/2. Well, the x values are √3/2 this way. It's √3/2 that way. It's √3 over, and in every single case where you can make an x value √3/2, it happens to be that the angle you make is pi over 6, right? That's what this is all about. That's why we only have to find this guy. Once we do that, we know that all the other possibilities are these guys right here, where each one of these is a pi over 6, right? Where all of the reference angles are pi over 6. And we know where all of them are, right? What's the one that's in the, which quadrant are we in here for this 0? Or for this solution?
Second.
So we're in the second quadrant. So in the second quadrant, what's the one that's over 6?
5 pi over 6.
5 pi over 6. So this is 5 pi over 6. We're back to our picture that you should have memorized and locked deep into your head. You go, oh, that one's 5 pi over 6. I don't have to use my brain. It's 5 pi over 6. This is the next one. Is in which quadrant?
7.
It's between these guys, and so it must be this guy, and it's, you told me, 7 pi over 6, which indeed is 7 pi over 6. And yeah, and think about it, right? We need, the cosine needs to be a negative value. It needs to be negative this. If you're thinking about the unit circle, the only time that x value is -√3/2 is if your thing is either right there, and you're talking about this point on the unit circle, right? Or if it's down here, and you're talking about that point on the unit circle, right? Which is what this means. That's what that means right there. So, okay, we got those. How do we get these?
Add 2 pi.
Okay, which gives me what? For that first one.
Pi for 6. Yeah.
Plus, so 2 pi is the same thing as 12 pi over 6.
17 pi over 6.
17 pi over 6, which
19.
does not reduce.
They never, 19.
They don't seem to, do they?
Unless it's like the 4.
Yeah. Yeah. So, okay, now what about this guy?
19.
19. 5 or 6. There you go. And so that's all of them. Okay. Check our time here. Okay, we're just now 12:30. So the last question. Well, there's an extra credit problem. No hints on that. Just you better be good. It's extra credit, so whatever. Now I just want you to see how it's a word problem. I want you to see. There's a lot of words. Okay, I can't shut up in case you can't. Lots of words there. It's very simple. It's very simple, and you could easily make it way too hard. You could make this so hard if you think too much about it. Don't think too much about it. If you have any questions, because Mika read this, and after laughing for a little bit, she said, she's like, this part of it could be confusing. You could interpret it, because guess what? There's an angle that's measured. And so, you could interpret it a couple different ways. If there's any question, just ask me. And it's so simple. Like, it's so very simple. And to give you, but there's a catch. I give it in degrees, okay?
Oh.
And so I am looking for an exact answer. And the way that you do exact answers in degrees is if your answer happens to be, say, sine 53.2 degrees over 101, that's an exact answer.
So
That is an exact answer.
We can't convert to radians.
No, don't bother. Don't bother. Okay, and it'll, you'll see. Like, I even take care of that in the problem. Like, it's made to, you're supposed to answer like this. Okay, your answer should look like that. And you had better use a degree symbol in this class. If we're ever talking about degrees, you must use degrees. Okay. So, for instance, let's say you set up your problem and if you draw a picture, there'll be no question about what this is. Okay. And so let's just say, let's say this. Let's say you've drawn your problem. It looks something like this. And, I don't know, maybe we measured this at 78.1 degrees. And let's say I don't want to use that. I do want to do this. Let's say you know that this is, let's say you know that this is 100, and you want to know what this value is right there. And I tell you, tell me what value that is right there.
Wait, do we do this?
Oh, we hit the bottom of this thing.
But it doesn't matter, because, wait.
Oh, maybe, yeah, probably, but that's, yeah. Now, I'm not giving you a hint here. Like, your triangle, it's a triangle. It's going to be so similar to this. I don't want you to think too hard, though, and like, if there's any questions about that distance you gave, is the distance this or is the distance this, you could ask me. It should be clear which one I'm talking about. And if it's not, if you draw it out, if you've assumed the wrong thing, but you draw it out, and I go, okay, that's what you assumed. That wasn't what I said explicitly. But I'll give you the benefit of the doubt because you've drawn it out. So draw out your triangle, and now tell me, how are you going to solve for y?
Y squared plus.
No! No! How? You don't know what this is? You have no clue what this is.
Well, we know.
So think about it. You have an angle and two sides.
We know cosine of 78.1.
You know that cosine of 78.1 degrees is equal to what?
Y over
No.
And so therefore y is equal to what?
100 times cosine.
There you go.
So it's just like,
And if you don't write that degree symbol, I'm probably give you a 0 because I'm so dead set on anytime you use degrees, you had better use a degree symbol. And so that's that. That's what that height is right there. That's it. That's an exact answer. Okay? That is what I'm looking for. It'll look very similar to this. Like your answer should look very similar to this right here. Okay? Yeah. So if I say like, you know, the distance, if I said, if maybe, for instance, if I said like, here's a position, and here's another position, something, and I say that the distance over the ground is 100 meters, which side do you think I'm talking about
The
here?
bottom.
You think the bottom, right? You'd think the bottom.
The opposite.
But it's over the ground. Wait, is it?
Yeah, like the distance over the ground. So if you're measuring over the ground, right? We're not talking about measuring over the ground, right? So I'm basically telling you which side of the triangle right now I've put in the quiz.
Okay.
Okay? Like if I say we're measuring something over the ground, this is the side I'm talking about. And that was what my wife was, well, no, there's another part. And it could be confusing then, like I give you an angle. Well, there's two possibilities of where that angle could be. If there's ambiguity, one, just think about the picture you've just drawn and see if the one that you're thinking about makes any sense at all, if you have the wrong one. If it makes, and think about just like what I've said in it, like how would you... Anyway, but my wife seems to think that's confusing. If it's at all confusing or you're not 100% sure what you're talking about, ask me. And even if you are 100% sure, make sure you put the angle in the correct place. Like if you think it's this one, write it up there. If you think it's this one, write it right there so that I know what we're talking about here.
Yeah.
How did I put it? Let's just see.
We can see it on the recording.
Yeah, it's some meters away from you across flat ground. That many meters away from you across flat ground. You shouldn't think that it's that way. Like, right? So that should be pretty straightforward. Yeah. So, okay, that's all I got. Then there's an extra credit problem, which is...
Oh, I thought that was it.
No, that's not the extra credit problem. That's the one application problem that we're going to make.